Hi there once again. On this video you're going to learn about discrete random variables. Okay, now this name sounds very technical, okay, but as you do more stats, especially when you move on to statistics too, you won't find these terms very daunting, okay. Right, discrete random variables. Okay, now I'll just give an example and then you'll see what it means. All right, so you have a discrete set of events. Okay, so an example would be you throwing a dice, okay, a fair dice. Okay, what are the different discrete events that you could have? You could have a 1, a 2, a 3, a 4, 5, or a 6 when you throw a fair six-sided dice. Okay, now what's the probability? So that's the outcome, x. Now the probability of getting that outcome. Okay, if your outcome was 1, what's the probability of getting a 1? If it's a fair dice, then the probability is the same, isn't it, for each outcome? Okay, so here you have a distribution of a discrete random variable. Okay, discrete because you have discrete events. Okay, and those are random. Okay, there is no, it's not fixed. Okay, it's random. Okay, you could get any one of these 6 outcomes. It's a random outcome. Okay, and it varies. Okay, all right, so that's what this means. Okay, discrete random variables. Okay, a random variable. Okay, now let's say if this dice was biased, okay, towards a certain number. Okay, even that could be called a discrete random variable. Okay, so you have the same outcomes for this dice, but let's say one of the outcomes has a very high probability. Okay, and so therefore that has to be compensated. Okay, let's say, okay, so because I gave that a higher probability, I'll have to take some of the I could reduce the probabilities for 2 of the other outcomes, so that the distribution, the probability distribution, if you add up all the probabilities for the different variables, it always should equal 1, isn't it? Okay, so that's just the fact that you've always known that if you add up the probabilities of all the events, okay, it should be, of all the outcomes for a certain given event, it should be equal to 1. So if I add all of these up, I should get 1. Okay, so even this is a discrete random variable distribution. Okay, the probabilities are slightly different. Okay, but it's still a discrete event and it's a random event. Okay, right, good. Sometimes you can find the probability of a certain outcome could be found by you substituting the value of that outcome in a formula, into a formula. Let's look at this example. All right, for this event the outcomes could be anything from 1 to 5. Okay, so this event could have outcomes anything between 1 to 5. Okay, but they are discrete outcomes, so it could be 1, 2, 3, or 3, 4, or 5. All right, and to figure out the probability of any one of these outcomes, I substitute these values into this formula and it will give me the probability of a certain outcome. Okay, so if I said, okay, now what's the probability of getting a 1, I substitute 1 for x. Alright, and I get a probability of 0, because that's 1 minus 1 is 0, 0 divided by 10 is still 0. I do the same for 2. I ought to get a 10th. Okay, so if I did it for the rest, I would get a 10th, 2 tenths, 3 tenths, and 4 tenths for 5. Okay, and if you notice, even if you use the formula, your formula has to be well thought out, so that for all the different outcomes for that event, the probabilities, individual probabilities, should all add up to 1. Okay, because if I add all of these up, so if I, let me first put this into a probability distribution table. All right, so those are the different outcomes. So 1, 2, 3, 4, 5. Okay, so if I add all of these probabilities up, I get 10 over 10, which is equal to 1. All right, good. Now you could get asked questions like this. Okay, so these are the outcomes and these are the probabilities for these outcomes. So what's the probability of you getting greater than or equal to 3? That means the outcomes that you could have are 3, 4, and 5. Okay, so therefore you got to add the probabilities of this, this, and this, and that will satisfy this inequality. So that's 2/10, 3/10 plus 4/10 is equal to 9/10. So the probability of getting 3 or above is 9/10. Let's do another one. Probability of getting equal to x is equal to or less than 2. So that includes the probability of 1 and 2. So that's basically the probability of 1, which is 0, probability of getting 2, which is 1 over 10. So therefore that inequality, the answer to that is 1 over 10. Alright, sometimes just to throw you off, they could ask questions like this: probability of x greater than 3.5. Okay, so you don't consider 3, you only consider the ones that are above 3.5, which is 4 and 5. So the probabilities of 4 and 5 is 3 over 10 plus 4 over 10, which is equal to 7 over 10. Good. Okay, now we'll look at something called the expected value or the expectation value. Alright, so let's look at a probability distribution like this. So again, it's a throw of a dice. You can get outcomes which are from 1 to 6, and they are all of the same probability. They all have the same probability. So let's just say there was a competition, and when you throw the dice, okay, 6 times, okay, and for every number that you get, every time you throw the dice, you get the equivalent amount of money. All right, so if you threw the dice first time around and you got a 2, you get £2. If you threw it the second time around and you got a 4, you'll get £4. All right, okay. Now if you threw it 6 times, well, you would expect to get all the 6 numbers, isn't it? It may not be the case most of the time, but if you were to look at an average, this would be a safe bet, isn't it? That you'll get all these numbers 6 times when you throw it 6 times. Okay, so because they have the same probability, all right, you have the equal chance of getting any one of these numbers. All right, now to find the expected value, you've got to multiply every outcome with its probability. So for this is a 6th every time you multiply by a 6th. Okay, so the result of that is equal to 1 times a 6 is a 6th, 2 times a 6 is 2/6, you get 3/6, you get 4/6. I'm just losing the parallel effect here. I'm just lost it there, but anyways, you can see what I'm doing. That belongs to that. Okay, all right, I'm multiplying every outcome by its probability because it's a 6th, the same value of 6 that I'm multiplying it by. And then all of these values, if I add them all up, I get 21 by 6. Okay, so the expected amount of money you'd get is 3.5, 3.5 pounds. Okay, all right, because if you did get 1, 2, 3, 4, 5, 6, that will average itself out to 3.5 pounds per turn, isn't it? Okay, all right, so per turn your average amount will be 3.5 pounds. All right, So to work out the expected value, all you've got to do for any probability distribution, you look at all the outcomes they have for that distribution and you multiply that by the probability, okay, for each of the outcomes. Okay, so in this time it's not uniform. All right, that meaning each outcome has a different probability, where here every outcome has the same probability. Okay, now let's see what the expected value here would be. Okay, so that's your x, that's your px. So you've got to multiply every outcome by its probability. So 0 times a fifth plus 1 times a tenth. Sorry there, I was a bit clumsy. Let's do 2 times a tenth plus 3 times a fifth plus 4 times a fifth as well. If I add them all up, I get 3 plus 6 is 9, 9 plus 8 is 17, 17 by 10. The expected value per turn is 1.7. Okay, I know there are big values, I know there are small values. Okay, so you can get 0, you can get 1, you can get 3, 4 or 2, but the average value per turn is 1.7 in this occasion. Alright, the next thing we're going to learn is how you find the variance of a probability distribution. We've learned how to figure out the expected value of a probability distribution. Now we are going to learn how to find the variance of a probability distribution. Alright, now the formula for that is this. Okay, this looks a bit complicated, but it's quite straightforward, the procedure. Now this bit here, what you're doing there is you're squaring every x term or squaring every outcome. Okay, so that's 1, 4, 9, 16, 25 and 36, and you're multiplying that by the probability of that outcome. So everything, each one of those is multiplied by a sixth, and then you're working out the result of all of this. You got to add each term. All right, so that's a sixth added to 4 by 6 added to, that is equal to 91 over 6. Okay, so that's this part here. Now what does this mean? That's basically our expected value squared. The expected value, we found the expected value for that distribution, which was this 21 by 6. So I've got to just square that basically. So 21 by 6 squared. Alright, that's my expected value squared. So then I have to take this one away from this. So 91 by 6 minus 21 by 6 whole thing squared, and that will give you the variance. There was no time in the damn world. The answer to that would be this 35 by 12, or if I wanted to get the decimal answer, that would be 2.91 or 92. Okay, so that's the variance. That's how we calculate it. You first got to square every x term, multiply that by its probability, get the sum of that, and then you've got to get the squared value of our expectation value, and then subtract that from this value here, okay, and then you get your variance, all right, which is this. Good. Okay, now we'll look at this subject here, cumulative probability distribution. Okay, now this is basically a probability distribution, okay, but if you were to get its cumulative probability distribution, then what that would show is the probability up to a certain outcome. Okay, now if the first outcome is 1, again this example here is throwing off a dice, an unbiased dice, okay, so the probability of getting 1 is a 6, but the probability of getting up to 2, so that's 1 and 2, that's the addition of these two probabilities, which is 2 by 6. The probability of getting up to 3 is the addition of these three probabilities, which is 3 by 6. You can see how it works. So for 4, 5 and 6 is going to be 4 by 6 and 5 by 6, and here it will be 1. Okay, the probability of getting up to all of its outcomes. Okay, if you add all the outcomes, you get 1, don't you? All right. So if they ask, if they give you a cumulative distribution, so the other term is not, term that you use here is not px, it's f, a capital F. That means that will indicate to you that it's a cumulative probability distribution. So here, if they say what's the probability of getting, 5 or less than 5, that's basically, you just read this value off, and that's 5 by 6. All right. So if they change that to an f, then you can't use an inequality sign. You just have to say fx equals 4. That means the cumulative distribution up to 4, that means is this 4 by 6. All right. Okay, good. Now let me give you another distribution where it's not uniform, the probabilities, just so that you understand this better. All right, so let me give you a situation like this where you have 4 outcomes, 2, 4, 6 and 8, and these are the probabilities. Okay, so that's the probability distribution, but if you were to draw its cumulative probability distribution, that's a probability up to a certain value. So I've got to replace the px with an fx. So now for 2 is just 0.3, but the probability of getting up to 4, which is 2 and 4, 0.4. Probability of getting up to 6 is 0.9, because you add that 0.5. Probability of getting up to 8 is 1. Okay.